Hello friends, in the last video we have discussed about carryover factor, stiffness factor and distribution factor. Now let us discuss the steps which are to be followed in moment distribution method. First of all, you are supposed to identify the moment whether it is 0 or non-zero. Then calculate free bending moment and fixed end moment. After free bending moment and fixed end moment, you are supposed to calculate distribution factor. For distribution factor, you can use table, joint, member, stiffness, K, summation of K, distribution factor which is K divided by summation of K. Then very important step, that is the heart of this moment distribution method, that is moment distribution table. After that, net bending moment and if required shear force diagram, which is rarely asked to you. Now here you must note that if any support is simple or overhanging, then the moment of that support is known to us, and therefore there is a step of initial moment. But if both ends are fixed, no initial moment. Fixed moments itself are the initial moments. Now let us discuss how to prepare moment distribution table for two span continuous beam. If we see, there are various possible cases of two span continuous beam. If you will see in the first diagram, both end supports are simple. In second, one end is simple and another end is fixed. In third, both end A and C are fixed. In fourth, support A is simple, support D is overhanging support. Like that, there are different cases, and we should practice first of all moment distribution table. Here I have assumed that you can calculate fixed moment, you can calculate distribution factor. In this particular portion, we will only discuss how to solve moment distribution table, because most of the time this is the crucial step where students find the little bit difficulty. So for this table, first of all you have to write joint. For example, in this case, joint A, joint B and joint C. After joint, you are supposed to write member, which is member AB, member BA, member BC and member CB. Then whatever the factor you have calculated, that you are supposed to write. Here I have just assumed some number. Say the factor for member BA is 0.3 and the factor for member BC is 0.7. This is randomly I have assumed. Then we are supposed to write the value of fixed end moments, that is FEM. Let us assume due to some loading the value of fixed end moment AB is 30, value of fixed end moment BC is 50 and value of BA is 50, BC is minus 60 and CB is plus 60. Now after writing this fixed moment, here we know that support A and support C are simple, and at simple support the moments are 0, and therefore to make this moment 0 we need to apply equal and opposite moment. For example, at support A the moment is of minus 30, that is a fixed moment, but the actual moment is 0, and that's why we need to apply a moment of magnitude plus 30, so that the final value of moment at support A will be 0. Similarly, we will apply the moment of minus 60 at C, and after applying some moment, if far end is fixed or continuous, half the moment with the same sign need to be carried over. Therefore, 30 positive, half moment with the same sign is carried over at B. Similarly, at C, minus 60 and half moment will be carryover, that is minus 30. Now after carryover this moment, we are supposed to calculate initial moment. As we know, moment at A is 0, moment at C is 0, but here the addition of 50 and 15, that is plus 65, and minus 60 minus 30 is minus 90 and 0. Now if you observe joint B, on one side there is a moment of 65 and another is 90, which is not equal in magnitude. Therefore this joint is called as unbalanced joint. To balance this, first of all we need to find the difference of these two moments. Here the difference of these two moments is minus 25. Now this is unbalanced moment which we need to distribute in the proportion of their distribution factor. So this value is to be multiplied with the distribution factor. Here that factor is zero point 0.3 or zero point 0.7. But we need to remember that if unbalanced moment is minus, it should be distributed with the opposite sign. So whatever the unbalanced moment need to be multiplied with the distribution factor, and it should be distributed with the opposite sign. So minus 25, so here minus 25 into zero point 0.3, that is plus 7.5, and minus 25 into zero point 0.7, that is plus 17.5. Here you can observe that far end of B is A, which is simple, carryover is not possible. Far end of B, which is C, that is also simple, carryover is not possible. And in this step we have balanced the joint, and therefore we can go for final end moment. And you can observe moment BA and moment BC are equal in magnitude, opposite in direction. So this is what the table for moment distribution to span where both ends are simple support. Now if we see the another case, see here what is the change I have made. Support A, which was simple in previous example, here it is assumed as fixed. The rest of the things are same. Now what is the change? If we see the change, what is the change? Support A is fixed. We will write the fixed and moment. Now in previous example, what we have done, we have released both the supports A and C because A was simple. But now here support C is simple, it need to be released. Fixed support should not be released because there are some moment which we know, and therefore we will apply equal and opposite moment at C. You can observe that the moment at C is plus 60. Now we need to apply the moment of minus 60. As soon as we apply some moment to make it 0, because that support is simple, we have to release it, we should carry over half the moment with the same sign at the far end. The moment of minus 30 will be carry over at B, and now there will be a step of the initial moment. Now here minus 30 will be as it is, plus 50, minus 90 and 0. Now once we write initial moment, we should balance joint B. What will be unbalanced moment? Obviously unbalanced moment is the difference of 50 and minus 90. So unbalanced moment will be equal to minus 40. Now this minus 40 is to be distributed in the proportion of their distribution factor, which we have assumed in this case zero point 0.3 and zero point 0.7. So this, when we distribute, we will distribute with the opposite sign. Always remember, carry over with the same sign and distribute with the opposite sign. So here 40 into zero point 0.3, which is 12, 40 into zero point 0.7, which is 20, but as unbalanced moment is minus 40, on both sides we will write plus 12 and plus 28. Plus 12 and plus 28. Now this 28 moment will not be carried over at C because support C is a simple. But this 12 moment will be carried over at the far end, which is fixed. So half the moment with the same sign will be carried over at A. Now there is no other carryover is possible. Joint is balanced. It indicates that we can stop over here and we can do the calculation of final end moments. Now you can see here minus 24, here plus 62, minus 62 and 0. So in this way we can solve this table for one end fixed, another end free. In other videos we will see what will be happen when both end fixed, one end overhang, two end overhang. Thank you for watching.